So I'm telling you a story that started in 2014, the story of FAIR. When in 2014 we had a meeting in Leiden where a lot of people have been thinking. There were people from many places in the world, and not only from the life sciences, and there are people from the publishing world, thinking about where the value comes from digital data in research. And there we decided on a set of qualifiers for data that actually make them valuable. And they have become known as the FAIR principles, and of course the name stuck because this is such a nice acronym. But the basis is in the 4 words. The 4 words: findable, accessible, interoperable and reusable. Actually a ladder of 4 properties of research data that make them valuable. First, you have to make sure that the data can be found by whoever wants to use it. Then you need to make sure that not only can it be found, but also you're able to actually get to the data. Then you need to make sure that that data is actually understandable by the people that should use it. And then the last step is the reusability, is licensing, that is the actual content of the metadata, the description, so that people know what they're getting, so that it is actually reusable. In 2014 and in the paper in 2016 where these FAIR principles were published, we said it is important that this is for humans and for machines. And that is because as humans, of course, we can know about a lot of data sets, but there are so many data sets in the world that only a computer in the end will be able to find out those data sets that are relevant for any project. And that's why we are saying humans and machines. In fact, after a while, we changed it and we said it's machines and for humans. It is even more important that machines understand the data than that the humans understand the data, because machines can make it understandable for humans within a limited amount of working time. And the other way around is horrible. And yeah, missing out on data because you don't know it's there is really, really a pain. So I'm not expecting you to read this. The presentation will be available, and these are the 15 principles in detail that say how to make data, according to the people that were there together, how to make the data findable, accessible, interoperable and reusable. And a lot is on a lot of technical detail in here. And so what I'm going to tell you in this presentation is a little bit how to put that in practice. What do you need to do to make this happen? And I think an important thing that you will find out is that a lot of it you are already doing. So it's not that if you want to make data fair, that it will add a lot of work. It's just planning it in a slightly different way and preparing things slightly differently, and then you'll end up with data that is reusable and will save time in the future. Actually, in this call, the interesting part is you will start with a data set that already exists, and once you start working on it, you wish it would have already been fair because it would save you time. And that's the case for every piece of data that needs to be reused. You want to save time for whenever the person after you that will be using it will be reusing it. And who is the most likely person to reuse your own data? And that is yourself, actually. Of course, there are other research maybe working on with your data, but in fact, you really help yourself by making your own data fair, because you will need, if you're doing the analysis, you will need to go on with the analysis the day after a night of sleep. And many people will have the experience that it's not often easy to continue exactly where you left off, and having a good, fair, reusable data for yourself will actually help you do it. In 3 months, when a reviewer from a paper comes back and asks you to do things slightly different, it really helps you if your data is documented so well that you can actually make this specific change that they're suggesting. And next year, when another postdoc takes over from there, it's also useful if that data is very well documented. So I really think that making the data reusable is a very good investment. Now, there are a lot of other organizations that have picked up on this actually. So I started with the meeting in 2014, for which the poster is here completely on the left. And in about 2 years after that, the FAIR abbreviation has been mentioned in many different places. And it is the basis for the European Open Science Cloud, the EOSC in Europe. The European Commission mentions it in their data management plans. And there are several other funders that have adopted this. To our big surprise actually, also the G7 and the G20 within a few years mentioned the FAIR abbreviation for research data. Now, there is something that FAIR is not. So what it is, as I said, is these 15 principles that have some technical detail, but it is actually not a technical a set of technical standards. So FAIR is not a standard. You cannot actually use the FAIR standard. You can also, some people equate FAIR with semantic web, which is a standard. Semantic web standards are actually very useful possibility to make data fair, but it's definitely not the only way of doing it. Another thing that is very important to see with FAIR is that there is no O in the abbreviation. So FAIR doesn't mean open. If there is sensitive data in your data set, then you don't have to make it open. It is perfectly possible to make data fair without them being open. And the converse is also true. I've seen data sets that were open and absolutely not fair. So in fact, one of the first experiences that I had in the transition to open science was a researcher who told me, well, there's no problem. I will deposit my data set because they're asking it to be open. That was the phrase in those days. They want me to make my data open. Is no problem because nobody will understand it anyway. And that's exactly what FAIR is trying to avoid. Then, as I alluded to already, FAIR is definitely not for humans only. You really have to think about, do computers understand what I mean if I write it up? And nevertheless, no matter how much work we put in there, FAIR in itself is not a guarantee that the data can be reused. It has to be suitable for a purpose. It has to have a certain quality. That is not mentioned anywhere in the FAIR principles. So, one other thing that is very important to realize is that FAIR is not a yes-no. You cannot say data are not fair or data are fair. What we are trying to do, and this is also if you read the call text, in many places we say as fair as possible. It's always a spectrum, and there is no point in going the last percentage to make it slightly more fair and putting many years of work in there. So what we are really looking for is the steps that you can make to make data a lot more fair with not a lot of work, trying to get the most benefit out of the least effort. And so it is a scale, and what we will be doing, and this is also part of the Bring Your Own Data meeting that has already been mentioned, is analyzing how fair are you, how on the 4 dimensions F, A, I, and R, and where the steps can be made to be of most benefit and of least effort. So what does it mean in practice? So I'll go through the 4 letters and tell you some of the things that I've seen in looking at data management plans. I've been looking at data management plans already quite a lot, and I can give you some examples of where I think, hey, if this is in a data management plan, then it has been well thought out. So, first thing is that you have to decide where your data will end up. And there are all kinds of possibilities. There can be for a specific kind of data, there can be a repository that is specific for that domain of data. There can also be an institutional repository. Your institute may say all the data that is produced at our institute needs to come into our institutional repository. There are also national repositories where generic data can end up. And then some research calls for delivers such special data that it is often possible to make a special repository. Or people say, well, I'll publish it on my own website. Actually, if you look at the usability, the reusability, the fair potential for this, the findability is the highest in these domain-specific repositories. And therefore, that's actually the preference that I have. The special repositories also have problems with the maintainability in the future, because you want to make this data available for a long time. But where do you get the funding to keep your own special repository up for another 15 years? So that guarantee is not giving a guarantee for the findability over the long run. The next part of the repository that is important there is whether it's content aware. So if for instance, a piece of genome data is available and people would want to reuse that, the first thing they want to do is probably go into a genome browser. If that is part of the repository, that actually helps the researcher that wants to reuse that data. So it improves the findability as well. So this is another thing you can consider. Many public repositories nowadays also give you the option of getting a persistent identifier, and if that is the case, then I would really say do so. So this is really the way to get things. And then finally, on the findability page, I have register a data in a catalog. So especially if your data is not in a repository where other people would look for that specific kind of data. So if it's, for instance, if it's a specific ABR data set, but it's listed in your own institutional repository, people would not start looking there for it. So then make sure that a catalog of data repositories would link to your data set from there. So describe it in a catalog. There are many catalogs. There are actually also catalogs of catalogs, so that you can find these when you're making your planning. So then, moving to accessibility. What is important for accessibility? Well, one of the things I already mentioned is actually that you have to make sure that the data is available for a longer time. What the FAIR principles actually tell you explicitly is make sure that even if the data expires, for instance, because of legal reasons, because you are not allowed to keep it for more than 15 years, you want the metadata to stay available for even longer. People should be able to find out that the data has existed. And people that have referred to the data can then still find out that the metadata still exist. So that's longevity. Another aspect of accessibility is the legal conditions. And I put it out here as two different parts. So if you need consent to have the data reused, it really helps if that consent is as broad as possible. So if the consent is really only for your study, then of course the reusability in the end will be very, very limited. Something else that you have to think about is whether data is anonymous or pseudonymized. Anonymous, of course, has a larger accessibility but a lower reusability. So you have to see whether there is a balance, and maybe it is even possible to have part of the data, or under different conditions, have it available under pseudonymized and have it broader available in an anonymized form. What I've always find very important if I look at a data management plan regarding fairness is that the embargo that is given on the data is limited. And what I mean with that is if people say the data will be released as soon as the paper is coming out, then I say, which paper? Cynical me. Or and what if the paper never is published because it was rejected, or when the results were not what you wanted? The data have value in itself. That's the principle behind FAIR. So I would like to see the data being available even if you don't have a paper, even if you do not get a patent. So don't limit it to link it to other things. You can say, okay, the data, we will keep the data for ourselves until 6 months after we made it fair enough for ourselves, or at the end of the project it will be available, then the embargo will drop. But at least make sure that there is a definite limit. Another thing that is very relevant for accessibility is actually the ICT procedures. So if you're keeping your data in your own lab, then it might run into problems with backups, unless you have very good IT procedures. If you're using professionals to maintain the ICT systems, there is a larger chance of actually having the data available at the end of the project. And by the way, repositories also have different policies for their accessibility. And repositories come often with a certification, and this certification guarantees, for instance, that if a repository itself goes belly up, that the data that is stored there will be available from another repository. They will actually do a transfer. And the persistent identifier will then make sure that people will still be able to find it, even though it moved. So interoperability is one of the most difficult ones, and it has very different aspects. The first thing is, let me first say, what do we mean with interoperability? Interoperability, I think, comes in circles, in concentric circles. The first level of interoperability that I would want to have is, if I do two similar projects, research projects, one after another, that I could bring those data together, and if I understand one, I can also understand the other. And I could merge them if that would be useful. The second level is when I have a colleague in the same lab that can do similar experiments, that when I merge my data with the person, with his data, that this actually delivers something that is intelligible. The next level of interoperability is if I collect data and somebody else in a similar lab, somewhere else in the country or somewhere else in the world is doing a similar experiment, that we agree on standards and on representations that are compatible. And the last level is actually interdisciplinary interoperability, and there it is whenever you want to merge your data or use your data in concert with data from a completely different field. And I was at a conference about research data in Botswana last year, and about 1 in 3 lectures there mentioned the Sustainable Development Goals of the United Nations, and of course here we are very close to those as well, where for all of those, interdisciplinary interoperability plays an important role. But the further out you go in these concentric circles, the more work you need to do to make the data interoperable. You need to be more and more accurate in how you describe your data. So there is again a benefit to looking how far you can go. So the first step, as I already show here, is the format of the data. So we want people to use formats of the data that is similar to others. If there is a standard format to store sequence data, FASTA, BAM, then please use the same one as the rest of the community. As simple as that. More complicated, but there will be a very specific talk about that after that, is the terminology. And there you have to think, can anyone, including a computer, misinterpret what I'm saying? Is it specific enough? And how specific, even if I don't need it very specific, maybe a reuser may need to make it very specific. Do your colleagues use the same term? Is a very good test for that. So I give an example here. We want to be able to see, and a computer can't just see, that cancer and malignant neoplasm actually are the same thing. Still, in medical research, we would use an encoding for such things. Once ever we go to interdisciplinary interoperation, we also want to make sure that locations and any other kind of columns in your data, any other kind of data fields that may not be medical, are still interoperable. And there we need to go outside of our own field and ask, for instance, a geographer how he would encode a location. Last thing for interoperability is, and that's we've already had it with Findable, you have to have sufficient metadata to support the interoperability. Reusability. That's in all of the principles of the reusability actually say something about metadata, and there are some specific kinds of metadata that I've lifted out here. So the data provenance is very important, and this includes simple things like who is responsible for it and where is it coming from, but also which software was used to process it, and which settings of those software packages did we use. What kind of machine was used to collect the data, and what were the settings of the machine. Which software was running on the machine, which firmware was running, because you want to be able to see whether that is reliable. An example that I had from a while ago, microarray data were often very unreliable. At some point, people found out that when you are running a microarray machine, it's very important to know what the ozone level in the environment is. So, all the data that document, for instance, the season at which a measurement was made earlier, you can deduce a little bit about what the ozone level was. So the data provenance even needs the season of the earlier data. Of course, now, when we know that, we just register the ozone level in the environment in the metadata file, and then we can reuse the data as well. So data provenance, everything, where does the data come from? There are many standards for this, actually. There are standards for different kinds of experiments that say what kind of metadata you minimally need to be able to use the data again. This doesn't mean, of course, that you should minimize the amount of metadata that you're actually recording. The minimal metadata is the absolute minimum, and I really suggest that you go beyond it if possible. Don't throw away metadata. If you have metadata that maybe is not useful for you, but you have it, and you store it alongside with your data, you may actually help the data to be reusable by others. An example of this, if you have a population and a reference population, and you know the age distribution of both, in your paper you will probably write that the age distribution of the control and the standard population were the same. But you had the population distribution, and the distribution can actually be usable for a reuser of the data. So keep it, don't throw it away and just say that it was equal, but actually describe that kind of data. The data license is something that's very important. Here we are reusing maybe a single data set, but you probably also have experience with data combinations. And licenses are very hard to combine. So a liberal license, trying to make as few restrictions on how people can reuse it, except of course for privacy requirements, legal requirements, that's fine, but copyright requirements as few as possible. And then the last thing that I have in here is to make sure that the results are not only narrated. We tended to put things only in papers, and maybe after a while we put data in supplementary data, which make them very, very hard to find. But the main part is in narrated text. And we want to have the data actually supporting that narrated text. The data actually should also contain most of the conclusions. And data scientists will be able to help you. And that's actually where I come to the end of my talk. It is very important that you address yourself to experts. We've had it already said in previous talks as well. Make sure to make contact with the data experts in your own institute. And yeah, in that case, you will see that this extra work that you're looking up to now actually will save you a lot of effort later. Yeah?
What do you mean with that? Persistent identifier?
What do I mean with a persistent identifier? A persistent identifier is a key that is understandably leads to that particular data set. So for instance, for papers, the DOIs are persistent identifiers. The identifier itself will never change, and it will always lead to that paper. And you can make the same for data sets. Actually, some people use DOI also for data sets, but there are other possibilities as well. An ORCID is, for instance, a persistent identifier for a person, for a researcher. So you are asking about the difference between pseudonymization and anonymization. In the law, there is only a distinction between anonymization and non-anonymous data. So anything that is non-anonymous can be led to a person, and therefore has to be very carefully treated. Anonymous data as you correctly say, can never be traced back to a person. Now there are several things that make this very difficult because we can do all our best to anonymize a data set, but combining it with something else may be able to re-identify it. In some cases, you can re-identify a person by typing some of the characteristics from a data set and finding him on Facebook. There are several ways of re-identification. So indeed, if you really make data anonymous, this you need to take into account. Data aggregation, whereby a standard of at least 15 people come into one group and you only have averages, is one way of solving that. There are other ways whereby you actually modify the data. So for instance, you never put the complete birthday of somebody in there, but only the birth year. Or you don't give a guarantee about the absolute accuracy, but you jitter all the data around a little bit. Of course, the reusability of the data then will suffer. So on the one hand, you will, by making the data anonymous, will increase the reach of the data, but you will decrease the things that people will be able to do with it. So you need to balance those two aspects all the time.